Hello everyone. Welcome to the solution of LeetCode problem 1572 named matrix diagonal sum. In this problem, we are given a square matrix and we have to return the sum of the matrix diagonals. But there is a condition. We have to only include the sum of all the elements on the primary diagonal and all the elements on the secondary diagonal that are not part of the primary diagonal. Anyways, let's consider the first example. Here we are given a 3 by 3 matrix. The value of this matrix are 1, 2, 3, 4, 5, 6, 7, 8, and 9. The value of the primary diagonal is 1, 5, and 9, and the value of the secondary diagonal is 3, 5, and 7. But 5 appears in both of the secondary diagonal and the primary diagonal. So we have to include the value of 5 once. So here the summation of 1, 3, 5, 7, and 9 is 25. So in this case, we have to return 25. Anyways, I hope you understood the problem. Now let's move on to the constraint. Here, n is the number of row or the number of column in the matrix. And the value of n can be in between 0 to 100. And each of the matrix element can be in between 1 to 100 as well. I hope you understood the problem. Now let's move on to the solution. Here we are using one custom example of 5 by 5 matrix for the analysis of this problem. So this is the custom matrix. And now we have to determine what is the diagonal path sum of this matrix. So we have to include the value of this diagonal and this diagonal. But 1 appears in both of the diagonal, so we have to include ones. Anyways, let's see how we can solve this. At first, when we are given a 2D matrix or two-dimensional matrix, our first approach is using the two loops or the nested loops. But in this case, the nested loop complexity can be equal to big O of n square, which is very expensive. So we should not use nested loop here. Anyways, let's try to understand this problem by using one loop or by using big O of n time complexity. Now let's see how we can do it. Anyways, we have to run a for loop for each of the row from 0 to 4. Suppose we are currently presented in the row 1. Now, by default, our left pointer value is 0 and our right pointer value is 4. Our left and right pointer will indicate the value in the column. Anyways, for the first row, our left pointer value is 0. So we have to take this element 1 and our right pointer value is 4. So we have to take this element for the summation. So we have to take 1 and 4. Anyways, our current pointer is pointing to the second row right now. But before that, we have to increment our left pointer value by 1. Now our left pointer value is 1 and we have to decrement the right pointer value by 1. So our right pointer value is 3. Anyways, for the second row, our left pointer value is 1. So currently this is indicating this element. And for the second row, our right pointer value is 3. So currently this is indicating this element. So for the second row, we have to include 6 and 2 in our resultant array, which is this. Now, currently our pointer is pointing to the third row. So for the third row, our left pointer value is 2 because we are incrementing it by 1, and our right pointer value is 2 because we are decrementing it by 1. Now, both of the left and right value is same because 2 and 2 are equal. So both of them are indicating this one. But wait, should we include this one 2 times? No, absolutely not. This is prohibited in this problem. So we have to include the value of 1 for the third row exactly 1 times. Now our current pointer is indicating the fourth row and we have to increment our left pointer. Now our left pointer becomes 3 and we have to decrement our right pointer and our right pointer becomes 1. So currently our left pointer is indicating this 1, which is in the column index 3, and our right pointer is indicating the column which is index 1, which is this. So for the fourth row, we have to include 4 and 1 in our resultant vector. Now our current pointer is pointing to the last row. So for the last row, we have to increment our left pointer value by 1. Now it is becoming 4. And we have to decrement the right pointer value by 1. So our current right pointer value is 0. So we have to consider the column numbered 4 and column number 0 for the last row, which is this and this. 8 is for the 0th column and 7 is for the 4th column. So we have to include the value of 8 and 7 into our resultant vector. So we can say that the summation of all of this value is 34. So in this 5 by 5 matrix, the diagonal sum is 34. I hope you understood the algorithm. Now let's move on to the code. In this code, at first we are given a function diagonal sum. The parameter of this function is the 2D matrix given, and at first we have to declare our left and right pointer value. Now our current answer element is 0. Now we have to use a for loop which iterates in each of the row. For each row, we have to check either our current left and right pointer value is equal or not. If it is, then we have to append the value of a of il into the answer only one times. And after that, we have to increment our left pointer value and decrement our right pointer value by using 1 times. And if both of the left and right are not equal and left pointer value and right pointer value are inbound, then we have to add the corresponding element to the answer 2 times. One is for the left pointer and another is for the right pointer. And after appending, we have to increment our left pointer value and decrement our right pointer value. And after completion of this for loop, at last we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity of this program. In this program, the time complexity is big O of n because we are using one for loop to iterate each row, and the space complexity is big O of 1 because we are only using the constant space for this algorithm. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.